Hello and welcome everybody. My name is Tanmay Mehta and I am the General Manager looking after the RFID project, which is what I'm going to talk about right now. I work in an organization called CRIS, the Center for Railway Information Systems. We're the IT arm for the Indian Railways. And the Railways itself turns out to be one of the biggest railway companies across the world. Today's topic is about digitalization, and the RFID project is a key element for digitization stroke digitalization as far as the railways is concerned. I prefer to use the word digitalization because not only are we converting some information into a digital form, we're also changing business processes along the way. And as a part of the business processes that we are changing, one of the things that I like to talk and spend some time about is really what all went into the creation of the system. So what were the requirements that we were looking at? What was it that we were trying to do? So normally all of you would know of RFID as an integral element of an AIDC project, automatic identification and data collection. When we were looking at this project on the Indian Railways, one thing we decided was it's not going to be just identification. We're going to go way beyond identification and look at the complete value add to the ecosystem. As I said, it's not just a digitization project, it's a digitalization project. So we're looking at business process changes, we're looking at how do we really drive the organization to a different level and style of working. So the RFID project is a key element inside what's called the RAMS initiative of the Indian Railways, which really is about improving the reliability, availability, maintainability, etc., of the rolling stock, which is the coaches, wagons, etc., of the railways. As a part of this exercise, one of the things that we were really interested in being very in implementing was that we wanted to do something which is driven by standards. So interfacing and so on and so forth would always be standards driven. And we wanted to work in a manner which is completely vendor neutral, which meant that if a particular vendor left, I could slot in somebody else. I could also use multiple vendors simultaneously. Railways is really big. So we are definitely looking at multiple vendors playing in this field. One other thing, which was again fairly important because trains run around the clock as far as India is concerned. So everything had to be 24/7. It also had to be pan-India on a geographical basis. So what was really important was that the core activity of identification must always work. It did not matter whether we had a network, we had power. This doesn't make a difference. Doesn't matter where are you? Are you inside a tunnel? Are you on top of a hill? Are you in the middle of a desert? It must work. This is a little different from most other solutions because they assume network connectivity. But here we had to work in a scenario where backhaul network connectivity may not be available. That had an additional advantage that from day zero, anybody and everybody could access whatever is going on. Also, if you're talking 24/7, then disaster recovery as well as business continuity become integral elements of the solution. Associated with this, we wanted to be very certain that the solution is secure, so everything is completely protected, encrypted, including the data on the tags, which is protected against accidental writes. Because we are working with staff who work in the field, they're also working 24/7. They already have equipment with them. One of the key requirements from the staff side was that we should get equipment which is easy to use. And they were really looking at small form factors. They were not really interested in very large devices. From the management side, they wanted the best performance across the world and the best prices, the lowest prices across the world. That's a fiendish combination to be able to do, and we have been able to do most of it. So this is what we actually managed to do thereafter. And we were trying to get all of these things to fit. So RFID is not the only thing that is in the solution. As a part of the digitalization process, we're also working with what are called data matrix code. There are two examples which are there out in front of you. These are really based, both RFID and the data matrix code are based on standards from an organization called GS1, which is the global standards body for these areas. We have a partnership with GS1, and all the work that we are doing technically goes through them, and they will agree, disagree, or give us suggestions on what we do. So the interesting point out here is that we have used GIAI 202 encoding on the RFID tags, and we are using simple basic LLRP for evacuation of data from the fixed readers to the backend. Interestingly, we decided, because of the scale and the sheer amount of information that we need to move, that we will strip things down to the barest essentials. So we were not looking at very complicated implementation, very high levels of basic software. We actually stripped and deconstructed everything down to its basic elements so that it would run fast and it would run easily across the complete solution. So what have we finally land up doing? So my organization had to do the complete design. So in the background on the top right, you'll actually see the first 3D model that we built of the tag. Then there's a intermediate model, so on and so forth. And all of this has been done within the country. We actually did it de novo. We did not build on an existing thing because we found existing applications to have a whole bunch of issues with regards to the way we work out here. And the important thing out here, which is at towards the bottom, is the fact that we have to read these tags at distances of just 1 meter and at a speed of 160 kilometers per hour and higher. So we did our testing. It's achievable with GIAI 202. Yes, it's fully achievable. People will say that it's not, but yep, we've done it. We also had a very interesting requirement which came in from the field, that whatever work that they're doing, they should not be required to do data entry in the field. So other than initialization of the tags, there should be no requirement for anybody to actually go poking around on any keyboard or anything. And all of that had to be handled. So as a result, the tags that we have also have a user data area, and as I had said earlier, they are writable. So we actually had to create a nano database system, just 3072 bits, 3 kilobits, and it supports a whole bunch of features that you normally would expect from a full-fledged database. And we basically worked on the structure of the data as stored on the tag, as well as the application which is available on the back end on the mobile device, and I'll come to that in a second. And that's how it works. A couple of photographs just talking about our site installations. So the top left is a wagon, the middle is a coach. The diagram in the middle is something slightly important, and you see a vertical line right in the center, and there's an antenna just to the right of it. That's the distance at which we are reading. That gives you an idea. Most instances of tag reading, for example, on highways, etc., the distance is 7 meters, 8 meters. It's in multiples of meters. I am at 1 meter. That's the smallest distance that people normally read high-speed tags at anywhere across the world. So as a part of a development process, you will see various things going on. There are tags which have been baked in ovens because of high temperatures. We put them under situations where they will get bashed up. It works. And that's a really interesting part. People said it won't, but it does work. So we did a lot of testing, a lot of equipment was put up there, and we took a good hard look at what can be done, what can't be done. And the interesting part in our solution is that while we have all of the infrastructure for fixed readers, a very important element is using mobile. And I don't mean a mobile device, I mean the person's own mobile. That's primarily because Indian Railways is by our own device territory, and the SIMs are normally provided by the organization. So what we really wanted to do was to leverage the mobile phone that the person carries for connecting to the backend and so on and so forth. So the portable reader connects to the phone over Bluetooth, BLE, and it also connects to the tag which is in front of it. The interesting part was that when we were working with multiple vendors, and as I said, we wanted to be vendor neutral, one of the things that we found was that every vendor has their own set of drivers, and that became an impossible situation. So earlier, we asked the drivers to be written by the vendors. That was quite an exercise, because every vendor would make a mistake, and then I would be running around trying to find out solutions for the problem that had been done. So finally, the discussions that happened with the vendors resulted in the fact that they asked us to write one common API for all the vendors. So this came from the vendors, and we've done that. So all the vendor-specific details are actually isolated in what's called an API shim, and we have one common API for all portable readers, which does our job. As a consequence, we have unified security, and this is really important, we are able to continuously push updates from the backend. As I said, we are writing data onto the tags at the time of maintenance, and this data is to be updated from the backend. How do we do that without a user getting involved? By continuously pushing the data in the manner through the common API that we have done. So this was quite an exercise of actually implementing all of these things. And I'm actually quite happy that we were able to do it, because now the portable reader manufacturers really don't have to worry too much about the application, which continuously changes as business logic changes for us. They don't have to worry about it. And we are having everything functioning, which is great between them and us. Okay, looking ahead, what are we going to be doing? The area that we're really working on right now, among the other areas, but this is some area that is a little unique, which is the RFID middleware. Now, normally we've seen when we talk to vendors, they don't really talk about 1,000 readers being able to connect to a single backend. We want to do in multiple thousands readers connecting to a single backend. And then can we monitor all of these readers, again in a vendor neutral manner, again on a standards based methodology. And we want that whole solution to have disaster recovery and business continuity as an integral part of the solution. We don't want to later come back and try to think this out. So this is a very interesting problem when we talk about middleware, and we're talking about this level, and understand that our readers function 24/7, trains run continuously. So data is continuously flowing in from the field into the backend. We can't stop that monitoring. The number of trains we run basically in India carry the entire world's population in 1 year. So everybody listening has theoretically traveled by a train. So this is a very interesting exercise. The scale at which we are working is fascinating. And this is something that hopefully in the next couple of months, we would be able to execute. We have already got a technical thing up and running, but there is a lot of work to look at the stability part. The interesting part is most of the solutions which have been deployed worldwide can evacuate data, but can they also monitor all the fixed readers? A vendor normally just monitors his own readers, but we need to be vendor neutral because we're going to have readers and infrastructure which is for multiple vendors. So we need a scalable solution which can work with multiple vendors. In other words, is vendor neutral and is standards based at the same time. So we're looking at a lot of open source technologies as a part of it. So streaming engines, a whole bunch of things are coming inside it. And that is an integral part of the work which is already ongoing, which is the deployment of fixed readers across the country. So currently we are looking at about 2,500, 2,800 fixed reader sites coming up across the country in the next couple of years. Now, all of this is just one part of the solution. It's not the full solution. Because as I started off saying that we are actually looking at implementing RFID as a part of a larger data ecosystem. RFID sends in data, also uses data, but that larger ecosystem would run in a manner that allows reliability, etc., to go up. So all of this data, which is identity data coming from the RFID side, has to be combined with maintenance data coming in through trackside readers, through other equipment being used for maintenance. And the whole thing then has to be pushed and analyzed, and analytics has to be run on it, and AI/ML activities have to be done on it with a view of improving, as I said, reliability, availability. So the whole thing cycles back, and we started off by talking about RAMs as a concept, and I'm really going to end saying that RFID work that is being done right now in the Indian Railways is absolutely cutting edge work. My friends in GS1 are quite happy with the work we are doing with them, and the end result is likely to be a far more reliable rolling stock available with us, a much better customer experience, and all of this as of right now is primarily made in India. We've been doing it internally. We have been taking help from a whole bunch of people, but overall, it's been a wonderful experience working with people across the world, from America, Europe, all the way to the Far East. And that's basically it. So thank you so very much for listening. And I always keep saying, let's make it happen. Let's make IT happen. Let's be digital. Thank you so very much for listening, and thank you.